Scrum, waterfall methods, and all. What is followed is a CRISP methodology. Uh, have you guys heard of this methodology in what you've been studying, or have you heard of it before? If anyone is
Nope.
okay, so CRISP is actually, this is the methodology used for the data science projects where you go in. The first thing is you understand business, that how it works, what are the processes. Then you get into the data, you understand which fields are what, where are where is the data placed, how to get that data, what kind of data it is it text, videos, what kind of data is there. Then you prepare the data for your particular problem, that the way you do the EDA at the data understanding and data preparation stage, where you see that what actually is inside the data, how helpful it can be. You do the modeling, and it should be, obviously you should be able to explain your models, that how good they are performing, and wow, and you should be able to communicate those models, and that why did you use this particular model. One major problem which I see in interviews also, and in interviews and in resumes also, that people are using really high, just to use those big words like neural network and all. They just do, they have written it in their CV that we have used neural networks for this particular project. The problem with that is the question that I asked them, or majorly is asked, that why did you use this? Why didn't you use a simpler technique? Why didn't you go with that? Do you know the pros and cons of using neural network or not? This is a very important part there. I think, especially the people who are graduating in their resumes and all, be careful that whatever techniques that you have mentioned in your resume or in your particular project, you should have the answer of why. You do not need to have the 100% accuracy, but it's important that you should know that why did you use this particular approach. This question is very important when it comes to a data science job, because in other things it's quite clear what the technology stack is decided and you're going to be using those. In When it comes to modeling, there are different techniques available. You have neural networks, random forests, you have naive bayes, and different things for different problems, and different types of data, input data, and depending on the output also, that there are different techniques available. So you should know that while while modeling, why did you use this particular model, and why not any other? If you experimented it with this, then why did you start, what was your thinking process? That's really important when it comes to modeling. Then once your data is modeled, you have prepared it, you have tested it out. The testing part comes in evaluation, which is you have to evaluate your model, and sometimes it's a really hard thing to do, because sometimes accuracy wouldn't work. You guys, have you guys heard of class imbalance problem? Imbalance class problem? Any feedback? Okay, so you guys have heard of it. Okay, so basically, I'll explain what an imbalance class is. That I'll make an example. Let's say in a company, uh, there are out of every 100 employees, three employees leave. Three customers, instead of employees, there are 100 out of every 100 employees, three leave every day, every month. This is actually called a churn rate. It is a very interesting, it's a very old problem that is being, that people actually that is being followed for basically in telecom, that people are leaving the company and customers are leaving. This is called churn. They're churning, and let's say three of them are churning. Three of the out of three out of 100 are churn. Now you're given a problem that you have given a data of customers, and you are asked that find out how many customers will churn. Now let's say you do nothing and you mark all of them 100 and say that none of them will churn. what is your accuracy? And out of those 100, three churn, three actually churn. So if you talk about accuracy, what is your accuracy? Can anyone type in? Yeah, it's actually 97%. You didn't do anything. You just named all of them, 100 people that, you 100 of you are not going. And when you will be going to the client and you will be saying, I have a 97% accuracy, if he doesn't understand it, the sensitivity of it, he'll be over the moon. That, okay, you've received 97% accuracy and you won't be lying in any way, because actually the percentage is really low of the people who are leaving. But is this model any useful for the client? Not at all. It's not at all useful for the client. So this is a very major problem. I mean, so that means there was your important class, which you wanted to find out or predict, had a very small proportion, and that was the important one. The other wasn't that important. And your data should also, majorly, when you will get this kind of a problem, obviously your data would be skewed in one direction towards one particular class. That these people, let's say you mark uh, zero as the people who will stay, and one who are the one who are leaving. You'll have 97% of the data would consider of would be the people who are there, and only 3% of your training data would be the people who have left. So when you will be modeling it, those 97% will actually take over. They will be, you know uh, they will be the one focused, that they will be the one driving the learning part, because majorly you have been learning only that pattern, not the 3% mainly. So because that was too less for your machine, like you'll have 100,000 records, so 97 multi, if you take the same ratio, how many records of the people who are leaving would you have out of all? So how to deal with that? And second, how to evaluate that model? Now you cannot use accuracy over there. You need have other things for that, which includes precision recall, F1 score. These are the things you guys might study later on and all, but there are different methods. The point is, the modeling and evaluation gets trickier over here, and these are actually decided once you're starting the project, that what will be the, how will you evaluate your model? How will it be accuracy, or will it not be accuracy, or and it would be something else? Because that is very important to be decided initially. And then obviously thinking what kind of a problem you're solving, it will depend on that also. Last part, deployment, as we discussed before. This is also a very important part, that especially if you guys, one other, if you are now completing your, if you're near to, if you're in the senior year and completing your degree, it's a really important part for you also, that when you deploy, well, you should, once you completed your model, make sure that you deploy them someplace, preferably cloud if you can. If not, you should have that deployed models, you should have that for your final projects somewhere deployed. So because that is also a very important experience, and that is something that gives you an edge over other candidates when your CV is being looked at, and you can be asked questions related to that deployment, because it is a very, very important part. Sometimes we develop those models, we do work in our notebooks, but we can only run our notebooks. So someone will give us the data, we'll run it, and then we'll give the results. How will you deploy it? How will the data automatically come in and automatically the machine would work and give it result back? And how will the machine be automatically trained so you can move to the next project? That is when your project is complete. So you should know that what needed for the deployment, and obviously based on how fast the data is coming in, you'll have to define your strategy, how fast you can handle that data. Let's say your model is taking 2 seconds per two, 5 seconds a request for each request, and 15 requests come at the same time. Would it be a viable option to deploy that in real time? Would you, or would it be a viable option, or some other option would be required, that your model is working at the back end, data is coming in, it's being processed one by one as it comes forward, and then a response is given to the user that okay, this is the result. Maybe it's related to imaging, whether it's related to voice or anything. So you have to know that which of the projects can be deployed in real time and which of them uh, cannot be deployed in real time, and how and the technology stacks for both of them if you guys can. That for real time deployment you'll need this kind of an application, and for non real time deployment maybe Kafka, or I mean you'll need some other kind of technology stack. So how would you handle that? This whole process is followed in the when we are making a plan for a data science project, that how much time it's not based mainly on scrums. It's like we are at this particular, we are at the business understanding stage, we are at the EDA, exploratory data analysis stage, we are at the modeling state, and these things happen. And then obviously modeling requires a lot of research also sometimes, depending on the problem. So moving to some of the roles and the requirements of the the day of data when you're moving towards this data science, moving towards the data science job specification, and towards this side, there are different, as I explained earlier, there are different job roles available, which includes data an analyst, machine learning engineer, data engineer, data scientist. And this is kind of an uh, picture of what how important one role one how important a particular area is compare for these different roles. Like for a data analyst, sorry, tools, programming tools, not just programming tools, other tools like SPSS and all other, these kind of tools are really important. And visualization is really important. He doesn't have too much focus on machine learning, software engineering, and all that deployment cycle and all. You will be the data analyst would be more at the part of data preparation and data in this. If I link it to the previous slide, if it would be more at the part of data understanding and data preparation. This is the part where a data analyst would work, and also maybe at the business analyst part in the initial part. Now, the machine learning engineer will need to build the models. He requires machine learning. Machine learning in reality, it's good. It's very important for you to know what's the maths behind a uh, particular algorithm, so you so you can make a particular decision that which algorithm did you use. And for that, that is why I ask you guys that in your when you are doing your projects, it's really important that you have the answer of why in your mind, that why did you use this particular model. So these modeling techniques, which modeling techniques he'll be modeling it. So he'll be actually doing the machine learning stuff, that fit, train, and all. That all part would be done by a machine learning engineer, and he'll fit at the modeling stage. Obviously, the data engineer would be the one who would be complementing the machine learning engineer, because he'll be giving the data to him. He will be focusing on cleaning the data, building a data malt where the temporary data will sit in, or where or how the process of the whole data cycle would be. And I mean, not the whole process, but what are the things that would be needed in placing this data and cleaning this data. And some maybe he'll be managing the Hadoop part, or if it's big data, then obviously he'll be managing those kind of uh, technology stack of basically managing the databases and cleaning up the data. And he kind of sits at the data preparation stage, the data engineer. After modeling, the evaluation and deployment, majorly this is what differentiates a data scientist from the rest of them. A data scientist would be overlooking all of these things, should know all of these sides. And this actually eventually at the data at the deployment level and the evaluation method, that is the person that comes in front, especially visualization, when it comes to visualizing and presenting the results to the client, or doing the initial analysis of the problems of and the decision making part of how the project would be run, and then how it would be deployed. That is the data science. That is the data scientist.
actually helping all of these areas out, the data analyst, machine learning, data engineer, also interacting with client and having the holistic view of the whole project, and making all these decisions also, that where what is needed, and he should have the ability to be able to jump in and replicate any of these people. So data sciences, that's why I said that in Pakistan we are lucky, kind, I don't know, lucky or unlucky, I don't know that yet, but we directly start from being a data scientist, although usually it does not happen. Data scientist, if you see, if you guys use LinkedIn, and search for data scientist posts in Amazon or in any bigger companies in the US side, you'll see that they require 3 to 4 years of experience if they're hiring a data scientist. Otherwise, they'll be looking for maybe an associate or a machine learning engineer, data engineer at that particular level at the initial stages. So that's actually the real whole view of data science, of what these things are. So these are some of the projects, few examples of the projects that I have been doing, which includes sentiment analysis. Here we had a sentiment. This is the easier part. Obviously, this was done for a Pakistani bank where, we had to tackle Roman Urdu also, and it was a really interesting problem because Roman Urdu needed to be captured in sentiment, as it does not have any syntax, or it doesn't have any particular I mean any particular style, or even this spelling mistakes and all. So that made it a bit interesting, intriguing project which we did. Recommender engines, which I talked about, the marketing plan previously, generating automated marketing plans. Those are the kind of those will be included in recommender engine. Churn prediction we have discussed. Phone bot, yeah, this is a project that my team is doing with where we are handling voice, which includes voice verification, and we have to go through the research papers and look at those, and see that what kind of technologies to use, what is already there in the industry, and what kind of I mean, how to interact and understand it, you how to use the assistants and how to make them better. This is what one part which we are currently working in. Another project that I completed was, this is petrography automation, which is actually for UAE, where uh, where what the process is, how do they explore oil? They explore oil by picking up the rocks and taking those microscopic images of the rocks, and based on certain information from those rocks, they used to find out that, okay, where to drill, how deeper to drill, and what to expect, what kind of amount to be expect, and which fossil or which gas, which natural, which of these fuels to expect underneath. So those, that whole project, they wanted to be automated, and we worked with, obviously, as I told you, business and domain knowledge is really important here. We work with some petrographers in Dubai, one, I mean, world best knowns for petrographers, and we were able to automate that process. It was really interesting project, which actually obviously saves a lot of time. Their one image analysis actually costed them around uh,